In this lesson, we're going to learn about the ASA triangle congruence theorem. If you remember, in a previous lesson, we learned that in order to prove that two triangles are congruent, we had to prove that all of the corresponding parts are congruent. That means all three pairs of corresponding sides are congruent and all three pairs of corresponding angles. So for example, here, if we looked at the angles first, we see that angle L and angle H are congruent. We see that angle J and angle M are congruent. And we see that angle G and angle K are congruent. So we know that all three pairs of corresponding angles are congruent. Now how about the corresponding sides? So we see that HJ is 1 meter and LM is 1 meter, so they're congruent. We see that HG is 1.7 meters and LK is 1.7 meters, so they're congruent. And we see that JG is 2 meters and MK is also 2 meters, so they're congruent. So we've proven that all three pairs of corresponding angles are congruent and all three pairs of corresponding sides are congruent. Now, the ASA triangle congruence theorem is a shorter way to prove that two triangles are congruent to each other by using just 3 pieces of evidence instead of the 6 pieces of evidence that we just discussed. ASA stands for angle, side, angle, and I'm going to show you how that works. Now, I found this great demonstration for ASA on GeoGebra, and the author of this demonstration is D. Gibson. So I just want to make sure I give credit where credit is due. Now, the angle, side, angle congruence theorem states that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then those triangles are congruent. So if you look here at this completed triangle and compare it to this incomplete triangle, notice we have here angle A measures 42.3 degrees and angle A prime measures 42.3 degrees. So those are corresponding and congruent. B measures 65.1 degrees and B prime also measures 65.1 degrees. So they're corresponding and congruent. And the side in between that connects the two of them, AB is 7.2 and A prime B prime is also 7.2. So these corresponding sides are congruent. And so that is angle, side, angle. Now watch what happens here when I take point A and I drag it around. Notice how it's changing the angle measures and the side measures, and the incomplete triangle over here is copying it, right? So here, if I stop right here, angle A is 37.9, A prime 37.9, B is 90.3, B prime is 90.3, and AB is 6.5, and A prime B prime is 6.5. Now what I want to do here is I want to extend these two incomplete sides of this triangle until they intersect so I can get the remaining two sides of the triangle and see what happens. So let's take a look and see what happened. Side BC measures 5.1, and look at the newly created here, B prime C prime also measures 5.1. And side AC measures 8.2, and A prime C prime also measures 8.2. And finally, angle C is 51.7 degrees, and angle C prime is also 51.7 degrees. So you see, when we extended these lines to intersect, these other two sides, these remaining two sides and third angle, also ended up being congruent to their corresponding partners on the original triangle. Let's try another one to see if the same thing happens. This time I'm going to take B and stretch B all the way over here, and I'm going to take C and stretch C all the way down here. Now notice what happened again. A is 65.8 degrees, A prime same. B is 79.5 degrees, B prime same, and AB is 6.7, A prime B prime is 6.7. So now let's extend the sides and see if the same thing happens again. Extend here and intersect. And here we are. So let's take a look. We see that AC is 11.6 and A prime C prime is 11.6. And BC is 10.8 and B prime C prime is also 10.8. And finally, angle C is 34.7 degrees and C prime is 34.7 degrees. So this is kind of to show you how angle side angle works, in that when you have that angle side angle situation, the other two sides end up being corresponding and congruent to their partners, and the remaining third angle also ends up being corresponding and congruent. And so that is how we can tell that both triangles are congruent to each other. So let's take a look at this example here and use angle side angle to prove that these two triangles are congruent. So if I look here at angle C, I see that it measures 61 degrees, and so does angle F. So these two angles are congruent to each other. Then when I look at side AC, it measures 2.3 centimeters, and so does side DF. So these two sides are congruent to each other. So in order to prove that these triangles are congruent using ASA, I need to learn about angle D. Because remember that the idea behind angle side angle is that you have that combination in that order. It needs to be an angle, side, and then an angle. So the congruent side needs to lie between the two congruent angles. So then in order for these triangles to be congruent, I need angle D to be congruent to angle A. So how can I find that out? Well, I can use the triangle sum theorem. So angle E measures 74 degrees, angle F measures 61 degrees. Add them together and I get 135 degrees. And subtract that from 180, and that will give me the measure of angle D. So 180 minus 135 is 45. So now I know that angle D measures 45 degrees, which is congruent to angle A. And so now I have angle side angle. And so now I know that angle ABC, or triangle ABC, is congruent to triangle DEF. And I did that using the angle side angle triangle congruence theorem. So pause the video, take a look at this example here, and see if you could determine whether or not these two triangles are congruent using angle side angle. So if I look here, I see that angle M is congruent to angle J. They both measure 31 degrees. And I see that side MP is congruent to side JL because they both measure 62 inches. So that means that in order to prove angle side angle, or use angle side angle to prove that these two triangles are congruent, I need angle P to equal 110 degrees. So then I need to go ahead and add together 38 plus 31, and that is 69. And when I subtract 180 minus 69, I get 111. So angle P here actually measures 111 degrees. And while that is very close to 110 degrees, they are not congruent. So I am missing this angle here in order to get my angle side angle. Therefore, these two triangles are not congruent. Now take a look at this example and see if you could determine whether or not triangle ABD is congruent to triangle ACD. So I look at this, I see that angle B is congruent to angle C because they're both marked with one arc. And I also see that side BD is congruent to side CD because they're marked with one bar. So in order to get angle side angle, I need to determine whether or not angle ADB is congruent to angle ADC. Well, we can see here that line segment AD is a perpendicular bisector of line segment BC because it creates a right angle and these two sides are equal. So if line segment AD is a perpendicular bisector of line segment BC, not only is this angle a right angle, but this angle is also a right angle. So now I have my angle side angle, because angle B is congruent to angle C, side BD is congruent to side CD, and angle ADB is congruent to angle ADC. So these two triangles are congruent to each other. So now let's take a look at some proofs using the ASA triangle congruence theorem. So it says here, given angle MQP is congruent to angle NPQ and angle MPQ is congruent to angle NQP, prove that triangle MQP is congruent to triangle NPQ. So what I like to do next is take the given information and mark it on the diagram so I could see better what's going on. So angle MQP is congruent to angle NPQ. So MQP is right here, so I'm going to mark that with one arc, and NPQ is right here. I'm going to mark that with one arc. And that way I can better see that they are congruent to each other. Then we have angle MPQ is congruent to angle NQP. So MPQ is right here. I'm going to mark that with two arcs. And NQP is right here. I'm going to mark that with two arcs. And I can see that those two angles are congruent to each other. And so that's our given information. Angle MQP is congruent to angle NPQ, and that is given. Also, angle MPQ is congruent to angle NQP, and that's also given. So you can see here, I have my two pairs of congruent angles. All I need is the side in between. So if you look at that, side QP is the same for both triangles. So obviously, if it's the same, it's equal to itself. And that's what it says here in the third statement. Side QP is congruent to side QP. And so which property tells us that a figure is equal to itself? And that is the reflexive property of congruence. So now that we have our angle side angle, we can prove that triangle MQP is congruent to triangle NPQ because of the ASA triangle congruence theorem. All right, let's take a look at this next example. It says, given that angle A is congruent to angle C and E is the midpoint of AC, prove that triangle AEB is congruent to triangle CED. So let's diagram what we know. We know that angle A is congruent to angle C. So I'm going to mark one arc here and one arc here. And we can go ahead and put that in here in our first statement that it is given. And we also know that E is the midpoint of AC. Now think about what that tells us. If E is the midpoint of side AC, what that tells us is that AE is congruent to CE. Because remember, the midpoint cuts a line segment in half. And so this is also given. And that midpoint E gives us our third statement. Side AE is congruent to side CE, and we know that because E is a midpoint, which means that they are equal. And so the reason for that is definition of midpoint. So we have angle, side, and we need angle. So we need this angle here, angle AEB, to be congruent to this angle here, angle DEC. So do we know anything that will help us to determine whether or not these angles are congruent? Well, they're opposite each other, correct? Which means they're vertical, and vertical angles are congruent. So that is the evidence we need right there. So angle AEB is congruent to angle CED because vertical angles are congruent. And finally, now that we have angle side angle, we could prove that triangle AEB is congruent to triangle CED because of the angle side angle triangle congruence theorem. All right, next example. Given that angle JLM is congruent to angle KML and angle JML is congruent to angle KLM, prove that triangle JML is congruent to triangle KLM. So let's start by marking our given information on the diagram. So angle JLM is congruent to angle KML. So JLM, so this is angle JLM, and KML, this is angle KML. So they are congruent to each other, and we see angle JML is congruent to angle KLM. So JML is this smaller angle here, we'll mark it with 2 arcs, is congruent to KLM, that's this smaller angle here, we'll mark it with 2 arcs. So what else do we need to have angle side angle? We have our 2 pairs of congruent angles. All we need is a side in between. Well, look at it. The side in between is side LM, which is the same for both triangles. I think now we have all the evidence we need. Let's lay it out in our proof. So first, let's write our given information. So first we have angle JLM is congruent to angle KML. And that's given. And we also know that angle JML is congruent to angle KLM. And that is also given. So we have our 2 pairs of congruent angles. All we need is a side in between, and we've already seen in the diagram that it's the same side, LM. So we know that side LM is congruent to ourselves. And we know that that is the reflexive property of congruence. And so now we have our angle side angle. So angle JML, triangle JML, is congruent to triangle KLM, and the reason is the angle side angle triangle congruence theorem. All right, let's take a look at one last example. So it says, given that angle S and angle U are right angles and side RV bisects side SU, prove that triangle RST is congruent to triangle VUT. So let's mark our given information on the diagram. Angles S and U are right angles. So here's angle S, it's a right angle, and angle U is a right angle. And side RV bisects side SU. So what does that mean here? What does that make T here? That makes T a midpoint, right? And that also tells me that side ST is congruent to side TU. So hopefully you can see what's going on here already. We have here angle side, and all we need is this angle here in order to prove that these 2 triangles are congruent. So think about what evidence can I use to prove that angle RTS is congruent to angle VTU? Well, they're opposite each other, which means they are vertical, and we know that vertical angles are congruent. So now we're ready to build our proof. So first, we have that angle S and angle U are right angles. And we know that because it's given. Now think about what that means. If angle S and angle U are right angles, that means they're congruent. So angle S is congruent to angle U, and the reason for that is all right angles are congruent. The next piece of information is that RV bisects SU, and that is given. Now, if we look at the diagram, what did that tell us? That told us that T was a midpoint, and that also told us that ST is congruent to TU. So that is our fourth statement. ST is congruent to TU. And how do we know that? Because of the bisector. So that is definition of bisector. Now we've got our angle and our side. All we need is this angle, and we know that RTS is congruent to VTU because they're vertical. So that is our fifth statement. So angle RTS is congruent to angle VTU because vertical angles are congruent. And we can use that to prove that triangle RST is congruent to triangle VUT because of the angle-side angle triangle congruence theorem.